Hi, this is Luke Robbins. I'm going to give you a demo of my model converter and my viewer for PA3 and 4. So to start off at PA3, the model converter, I'm just going to get going and kind of show this thing in action. So I'm just going to run it from my resources folder, which is where I have like my textures and things like that, just because I need to have the access to the FBX that's actually being converted. So if I just go ahead and run here, you can see I list the files I can include in .spu. So for the Warbear, we've got the vertices, the UVs, the norms, the trilist, and two texture output files because there are two textures for the Warbear. And so let's take a look at how this works. So in the converter, it just takes all of the vertices that are created from the FBX and does that kind of second step of converting those into the types that we want to feed into our engine. So what I do is I just created three buffers, one for XYZ, one for UV, and one for norms. And then from there I just cycled through the vertices, building this raw data that's going to be fed into the files and then read into the engine. So there's those three. And then for the trilist, I can kind of do that in one fell swoop without having to do anything fancy. So I just get the trilist data into the buffer, and so what I do then is I write that information to file. So I literally just take the raw character array buffers and I send them to the to the binary file. So XYZ, UV, norm, and trilist. For texture, what I'll do is I load up the TGA files that meet this kind of this pattern matching. So for Warbear, it'll be Warbear anything.tga. So that will include Warbear Grizzly and Warbear Polar. And so that way I can get all of them, even if they're named differently. All they have to do is follow the convention of having the beginning of it start with the same name as the kind of file. And then for each one of these texture files that I get, I will read it in the TGA, I will get the information about it, and I can essentially package it with its own chunk header as part of the SPU file. And I do it this way, and what I do is I include its name, cur_texture, which is the file name, plus its index in kind of the names that we gathered here. So if there's three of them, it'll be like Warbear 0, 1, 2. And this way, when I look it up in the engine, I can kind of cycle through looking for those names, and I don't have to know exactly what the textures are named in order to find a variable number of them, if I have 2 or 3, and it will work. So I ran this earlier, and we can see in the resources folder the output, all the bin and blow files, which probably should be automatically cleaned up at the end, but the result is this SPU file, which we can see was just created at 11:02. And so what's going to happen is it's going to get read into the engine so I can display it along with my other models. And so here we can see I can just run it from a command line in a single line, and I'll show you that I have models from all of these. So I've got the Astro Boy, the Buggy, I've got the Warbear from Group C, and Group D is just the Dragon, which I got from, I think Cody posted it in the common directory. Each one of these have textures, and yeah, the game engine reading it in. So now it's kind of here's where we move over to the viewer side of things. So in the engine, what happens is I can load a model, kind of similarly to how we did it with just like the Azul files last quarter. So what happens is I'll load up the SPU file, and what I'll do then is I'll look for the chunk for each one of these different aspects of the vertices. So I'll look for with a model file name, I'll call eat on it, looking for verts type. I'll call it looking for UV type, for norms type, for trilist type. And then within eat, what I'll do is I cycle through all the chunks in the SPU file, and if the chunk header type is what I'm looking for and the chunk name is correct, then we know to load that raw data into the buffer. And I can do that for all of these pretty neatly. And then texture, as I said before, kind of my convention right now, 10 is kind of arbitrary, but you can read up to 10. And so what it'll do is this text name will be warbear0, warbear1, and only when not only is it the type, but the name is the one that we specifically looked for will it work. So for 0 and 1, this will work because we have 2 textures, but then 2 through 9 will just be ignored. And then once we get a texture loaded in, if it's successful, then what we do is we add it to our list of textures on the kind of texture list in the manager. And then within the game, we can create our models, and then we can set our graphic objects using a different texture name, and that will just look up the one that we loaded. So there's like warbear and there's polar bear, and so if we load up warbear0 is going to be warbear, warbear1 is going to be polar bear. So in this case, I just threw this in there as a little sort of initial way of handling this for limited data that we're working with. And in the future, I plan on kind of implementing a more dynamic way. But, I won't dwell on it now, but I'm trying to figure out how I want to do that. And if I want to have, loaded model itself have any knowledge of these different textures. And I probably think I will. But anyway, let's get to looking at it. So if we fire up the engine here, we can see everything that's going on. So we've got multiple instancing of the frigate, multiple instancing of the bear model, which was loaded from file. We've got the Astro Boy, the buggy, and the dragon. So warbear, we can see the different textures here, we've got the frigate moving around, and I'm demoing also the bounding box on the buggy and Astro Boy. I haven't implemented toggling, but I think that'll be pretty fast. I just wanted to get this demo out there. But for toggling bounding box, on my PCS tree, I actually have different sort of root branches. So I have the actual root, and then I have a texture object root, and then I have a color object root. And I think I would just add a separate root for bounding boxes and add those, or bounding spheres, and just add that to them. And kind of like the sprite batches in 456, you can just press a key and to toggle a switch, and that will decide whether or not to draw that branch of the PCS tree. But I just didn't want to worry about that until I got this demo out there. Oh, and also for the dragon, I also just wanted to show the pink texture for the uninitialized. And as we can see, we're moving around here in the camera. And there are still multiple cameras, which I implemented last semester. You can just press C, and you can go around. And I think I've got like 3 in there. And I think textures, if you want to swap texture by key, you can just hit T, and it'll swap to the next one. This is pretty rudimentary. It just swaps kind of to the next one in the list of textures. So if you hit the end, then it'll just wrap around. I think that's it in terms of showing a demo. I've got the viewer, I've got instancing as I showed with the warbear and the frigate. The bounding sphere, I'll do toggling in just a bit. Texture has a hot pink checkerboard, and it reads in the custom type that we created with the assets. So I think everything's working pretty well. I think at this point it's just about kind of cleaning up a few things and making it more scalable for when we don't need to hard code some of that stuff. So I made it work, and next I need to make it good and make it fast.